All right. So how many of you know about Microsoft Azure HDInsight? Does anybody knows about? So this is basically a service we run in big data, basically where you can get the HBase cluster on fly. So I have one slide explaining what is HDInsight HBase service is, actually. As you have known that HBase is a big beast, and managing that is very difficult. So we have a service on Azure which can give you on-demand cluster with a few clicks. It has out-of-the-box performance. We support both Linux and Windows. We have an enterprise SLA of 3 nines. We also give active monitoring versus telemetry, and we have 24/7 customer support. Right? If even at 2 a.m. at night your cluster goes down, we know it beforehand. We try to fix it before you even know it. So make sure that you have a very, very enterprise customer production. We have a lot of enterprise running on us. There is one unique feature which I like to talk about ourselves in our architecture is our storage is decoupled from compute. So our storage runs in the cloud, and our compute processing happens in the compute engine. That has few advantages because that allows our clusters to be ephemeral, because running anything in the cloud is expensive, right? You have to pay money as soon as you are burning your compute, so you can automatically scale your cluster down or scale up as your load in your system increases or decreases. Even if you have a very small amount of cluster nodes, you can write unlimited amount of data irrespective of the cluster size. You can delete your cluster and still your data is accessible. So you can access your data in case you want to just go delete your cluster. So that's, and you don't have a lot of HDFS kind of issues which you heard about here because you just things are in the cloud. This is our portal. This is, you go to data analytics, you create, say I want to create an HBase cluster, and then you fill out a few configurations, boom, you have a fully managed HBase cluster for you in a few minutes. This is a slide, a little bit of slide on architecture, is what you're getting when you get a cluster. Sorry. If you look at this, this is our HBase cluster. Basically, this is multi-nodes where we have region server and rest server running, multiple worker nodes. You can configure how many worker nodes you have. We have this red line you see is the HBase cluster we have here. We have a couple of gateway nodes. Again, it's an HA, it's a couple of gateway because we make sure that it's highly available. We have redundancy built in every part of the system. And then this blue thing is a virtual network, which is like a VNet. We can give you a perimeter security boundary, and where you can have your web apps talk directly to some of the region server. We support all the APIs, REST, Java, RPC. And as I showed that the cloud storage right now talk to the Blob storage account, or something called ADLS, we'll talk about a little bit more, is our storage where our HBase talks to this region server. This is we call it WAS, Window Azure Storage Blob. Right now, this is one of the most popular storages in GA form, where you can get about 30 gigabits per second bandwidth, 20,000 IOPS per storage account, and about 500 terabyte storage limit. It's not good enough, actually, right? When we have an enterprise customer, it's not good enough. So something we are right now in preview is something called ADLS, stands for Azure Data Lake Storage. Basically, this is a native big data storage built for big data. So it has a HDFS for cloud, unlimited capacity, petabyte of data if you want, very high throughput and low latencies because HBase require low latencies. It was built for HBase kind of workload, and it has a strong consistency. It has also very secure because it has file ACLs built in, all the security informations, scalable, reliable, throughput. It's a very big marketing slide, but but I must say it's a big data store that's going to be something. It's in the preview, but we are going to GA very soon. So coming back to customer case, why you guys are here. This was one big customer that came to our platform and say, it was an internal customer and say, hey, I want to run HBase. It was a real-time analytics platform. It's a telemetry platform and uses HBase for large-scale indexing. Empowers a lot of customers, Skype, Bing, MSN, Cortana, SharePoint, Office 365, so on and so forth. The scale of the business was this much. This was pretty high. It's 4 million events per second. It was generating about 12.8 petabytes of data per month. More than 500 million devices, unique devices that talks to these guys and data's coming in. More than 5,000, or 3,000 now, actually it's maybe 5,000 productions systems running against those things. Multiple storage account, about 500,000 IOPS per second. Pretty big system, right? And of course, the SLA and of course, needs to be more than 4 nines, actually, in this case, because of the very critical services running on it. So as a very good manager, such a big problem comes in, I go to my engineer there and to Nitin, hey, let's go solve this problem. So he's going to talk about his performance journey as how he thinks about as a performance guy, because we both have worked as performance for a long time, and how did he make HBase on HDInsight scale to that large throughput.
Thank you, Pravin. Hello, everyone. My name is Nitin. So, as Pravin has mentioned here that customer came up to us with such a high throughput need. I mean, I have worked on relational database as a developer for many years. I have never seen any customer demanding so much from one relational database. So this was a very unique opportunity and a very unique performance debugging experience. So when customer did early evaluation of HBase, he got the performance that was 10x lower than their requirement. So they told us that if you can give us 10x more, we will go with you. And this was a kind of a do or die situation for us. So basically we felt that if we make this one customer successful, we'll make our service successful. So one of the biggest concern that customer had was throughput did not scale from 15 node to 30 node. And that was like quite surprising to us, and it was a very big concern for us also. And that's where we started our debugging. Okay, so basically whenever we have any performance issue like this, right, where you need so much of performance, I mean, you definitely got to have plan, right? I mean, the performance problems could be unique in nature. This was also unique in nature. And if we don't make a plan, it's very easy to get lost and very easy to go get frustrated and then basically give up on it, right? So, I mean, this slide is very dear to us, to both me and Pravin. We have worked on countless number of performance problems in relational databases, fixed a lot of performance issues. So this has always helped us. This approach has always helped us. So the first thing we did was to understand the architecture. Like we worked with customer, we got what their architecture was and what is the end-to-end pipeline of the data movement. And then we tried to understand all core components in the data movement pipeline. And then what is the next thing? I mean, the next thing was to get the control of the workload, to run the, get the ability to run the workload. And since this was an internal customer, it was also easy for us because customer would give you more control, right? Like, okay, since we both work in Microsoft, here is get the control, run the workload, and debug the performance. So we started with that. We understood the architecture. We got the control of the workload. We automated the metrics collection, doing the profiling of all the components in HBase. And basically, we profiled the relevant components, identified the perf bottlenecks, made performance fixes. We checked whether we got the desired performance or not. And this was a very iterative process. I mean, we had to make hundreds of runs, and repeat these experiments for almost more than 2 months, and then we eventually got success. So basically, there are few important things which I want to emphasize in the right, that these are the ways through which you can save time, right? So when you have a very complex architecture, what can you do? The first thing you should try to see whether you can divide the problem. If you have several components, can we test each component individually? Can we perform some unit tests? Can we disconnect the pipeline and test individual components, write some targeted workload, and identify if this component is a bottleneck or not? So these are the exact same things we did in this performance debugging exercise, and I will come to those things later. And another thing is, when customer comes to you and says they have 100 node cluster and they are not getting the desired performance, what do you do? I mean, there are two choices. Either you debug on the 100 node cluster, write debugging infrastructure, and which is very difficult, it can take more time. The thing to think about is, can we reproduce the problem at a lower scale, maybe 1 node or 2 node or 8 node cluster? So those are the things we did in this performance debugging. All right, coming to the first thing, understanding the architecture of customer application and our service pipeline. So if you guys see this circle, this is the customer app. So the data from all internal Microsoft services like Bing, Cortana, Skype, Office 365, all those were staged into multiple storage accounts. They were queued here. And then customer had 300 VMs from where they were pulling the data out of those storage accounts, and they were ingesting that data into HBase cluster. So this cloud you see here is the HBase cluster. And that data was pumping through the gateway, and the HDInsight gateway does two things. One is authenticate the request, other is do the load balancing across multiple worker nodes. And on each worker node, which is one VM, we host two main services, which are REST server and region server. So REST server we use for the REST APIs. Customer was using REST APIs. And then eventually, data goes to cloud storage. So that was the overall end-to-end architecture we got from the customer. So this picture was very blurry to us. I mean, this would look clear to you guys, but this picture became clear to us after doing multiple iterations. So I will just quickly go through the initial iterations and what are the first set of issues we identified. So after doing the first run and collecting the metrics, the performance metrics, we found that the CPU utilization on all the worker nodes was very, very high. It was almost close to 100% on all the worker nodes. So then we figured out which process is consuming so much CPU, and it was the REST server on all the worker nodes. So then we did profiling in another iteration, in another run, and it was a targeted profiling for the REST server. And there after looking at the profiling data, we noticed that it was compression. That compression was turned on by default in the REST server. So compression is in general good, but for our scenario, we felt that we have enough networking infrastructure, there is a high bandwidth link between the worker nodes, and we definitely don't need, we generally turn on the compression for reducing the bytes sent per second or received per second from the machines. So we turned it off, and we saw a minor improvement in the throughput, but another issue popped up. So I mean, this performance debugging, as you guys would know, I always like peeling the onion, right? You first remove the first layer, and you don't know what the other layer will look like. So we first fixed the one bottleneck, then we realized there is another bottleneck, which was the GC. So we noticed very heavy GC activity on the REST server and region server processes. So So GC was consuming roughly around 80% or 70% CPU. So we tuned it. We tuned the parameters around max heap, mean heap. We also found some better algorithms for GC online. So we applied all those things. And then GC was under control. We could bring it down to 10%, between 10 to 20%. Then we felt this is fine. Now, in the next iteration, we saw again a little bit improvement in the throughput, but it was not sustained. Our target was 10x, right? So that's why I'm not mentioning even 10%, 30% improvement here. So the next problem which we saw was very interesting. What we noticed is that when the REST server process was every now and then consuming 100% CPU, and the overall throughput utilization was very, very bumpy. So whenever REST server starts consuming 100% CPU, the throughput goes down, right? So when we profiled this, we noticed that REST server had hundreds of handlers for handling the REST requests, and all those handlers were busy on the networking. They were waiting for network IOs. And there is a epoll wait in the socket library. They use epoll wait method, and they were most of the time waiting for a few milliseconds and polling and waiting and polling. And as a result of this, since we have REST server and region server process on the same machine, the REST server was starving region server from CPU. So region server was not getting enough CPU to execute, whereas the REST has dependency over region, right? If the region does not do work, REST cannot respond back to the client. It will impatiently continue to wait, do the busy wait, and that's how the entire thing was stuck. There was no progress for long time until region server responds back. Until region server gets the CPU, gets the quantum, responds back to the REST, and then REST responds back to the client. So now how do we fix this problem? So we had two choices here. Either we could give limited number of CPUs to the REST server, affinitize it to the limited number of CPUs, or another choice that bump the priority of the REST server process. So we went with another one, which was easier. Like we bumped the priority of region servers, and then this situation was quite under control. Then we did not see any instance where you would see 100% CPU utilization, REST server consuming so much CPU. So whenever it required region server to do work, region server will steal the CPU from REST, do the work, and give the control back to REST. So after this iteration, our issues were not all fixed, right? So we noticed another, definitely the CPU utilization was under control. We could see CPU around 50% or 40%. It was not 100% like before, but we did not get the desired throughput. So what we did is we again saw that the threads were waiting for network IOs. So what do we do here? So we collected TCP dump. We decided to collect TCP dump on all the worker nodes, on all the head nodes, zookeeper nodes. And we tried to understand the messaging between different components in the HBase. And that effort, I would say, did not go waste. We got really good insight from that TCP dump data. And that insight was that when a batch request of 1,000 rows comes to a REST server, the REST server was fanning out that batch to all the region nodes. So this was on our learning from the TCP dump. So, and then we came to realize that customer maybe is not using HBase in the most optimal way, right? Their batch, which they are submitting, is not getting localized to one region node. It's fanning out to all the region nodes, and because of that, the overall throughput is governed by the slowest region server. So until the slowest region server of all the region server responds back, REST server is waiting on the entire batch, right? It will not respond back to the client before all the region server responds. So the trick here, basically, we use salt bucket scheme to improve the locality. We proposed this to customer. They made some changes, and now any batch which comes to REST server was going to region server, one region node directly, and it was not fanning out like before. So that was quite helpful. So I would come to another slide which shows how much was the performance gain after doing all these fixes. So we got roughly 2.75x improvement after doing all these performance fixes, and our measurement window was nearly 72 hours. And average cluster CPU utilization was nearly 60%, but our throughput did not scale from 30 node to 60 nodes, so mystery continued. So it was, it was quite frustrating, but again we thought, let's step back and go back to architecture and see what we are missing, right? We had done everything possible from the HBase side, also proposed something to customer, fix their locality, but still we were not getting the desired throughput, and performance was not scaling. So we went back to architecture, we looked at it very closely, and then we felt, could gateway be a bottleneck here, right? So we have this HDInsight gateway where we had only 2 VMs, and then we looked at it like it was only 2 core per machine, per VM, and we did some math, and we realized, oh, that could be a bottleneck. So after that, our guess was right. It took us some time to get the access to the gateway because of the security reasons. Once we got the access, we collected the perfmon in Windows, and we looked at the CPU utilization. So if you guys see here, you would notice that the core 0 is more than 90% busy, whereas core 1 is 81% busy. And you would notice another interesting thing here, that the DPCs queued per second on the core 0 was more than 2,000, whereas on the core 1 was 54. So that means that all the incoming networking requests, right, they were all going to the core 0. So the network driver would always run their deferred procedures on the core 0 and not on the core 1. So the trick to solve this problem is using RSS. So you can go to the driver, the network driver, and enable the receive side scaling, specify how many CPUs you want to use for the receive side scaling, and then it can load balance the incoming network request to multiple CPUs. So our performance, after doing that, our performance improved a little bit, but it was still not significant because the CPU was anyway very close to 100%. And we also realized that it's not just CPU, we also could have the networking bottleneck, because on such a small size VMs, Azure could throttle us at a lower bandwidth. So it was time for us to try scaling up the gateway, and that's exactly what we did. So we configured our private gateway for faster turnaround. We used the open source Nginx as a custom gateway. We programmed it so that we configured it so that all the incoming requests will get authenticated, and will also load balance to all the region nodes, to all the REST servers. And then we confirmed that the gateway issue was indeed fixed. The CPU utilization was almost 5% or 10% on the gateway nodes, but the throughput problem was still not solved. We solved the gateway, but throughput was not solved. So again, the mystery continued. It was time again to go back to the architecture, right? So now we questioned, could client app still be a bottleneck? I mean, even though it looks like it has 300 VMs, so many storage accounts, so much of parallelism, could be a bottleneck, right? So we went back to client, but the bigger question for us was, how do we debug it, right? Let's say we assume client could be a bottleneck, but how do we debug it? So the trick here was, like, we again went back to our previous slide. Could we divide the problem? It's such a big architecture, so many components in between. Could we divide this problem? Could we do something that we don't have to go to the HBase cluster and just send the data to gateways and return success to the client so that we can test it under isolation? And this is what exactly we did. Since we were using this private Nginx gateway, we wrote some new rules in the in the configuration that whenever you get any request, just return success, just return 200 back to the client, so that client will feel, okay, he has done the ingestion and it is successful. So that is exactly what we did. We disconnected the gateways from HBase cluster and immediately returned 200. And that is how we were able to find many bottlenecks in the client. We eventually got those things fixed. We worked with the customer and we fixed the client bottleneck. So after that, client was able to send almost 4 or 5 gigabit data per second. Now, did the throughput problem solve? We connected HBase back after fixing all the client issues. It was not solved. We were still getting the lower performance, 2.75x better than our starting point, but we did not get 10x. So the mystery was still there. But one good thing was we had isolated the problem. We now knew that we definitely have some problem in HBase in one of the components, either REST server or it could be our cloud storage high latency, right? So we went to the route of isolating the problem. So we divided the data pipeline into 2 parts and debugged them in isolation. The first pipeline was solved, where we were sending data from the client app to the gateway. That was solved. The another part of the pipeline was sending data from REST to region to cloud storage. That was unsolved. So now here, we again went to our another strategy, which is, could we reproduce this on a lower scale? I mean, we felt that running on a 100 node, 60 node cluster is a very tiring process, right? We have to set up the workload, run the workload, it takes time. So could we reproduce the problem at a lower scale? So we did exactly that. We reproduced the same thing on smaller 1 node and 4 node clusters, and we used YCSB benchmarking tool to mimic the customer scenario with their row size, with their throughput needs, with their batch size, everything. And then then we ran YCSB workload locally inside the HBase cluster. We even avoided the gateway. We didn't want even gateway to be inside our pipeline. So after this isolation, since we were suspecting on only these 2 components, REST or Azure storage, we again did further division of the problem. We replaced the So we replaced the Azure storage with local SSDs. And then we compared the performance of REST APIs versus RPC APIs under isolation. And here were the results. We saw that REST only gives us around roughly 12K to 20K on 8 nodes, and RPC gives us very high throughput. So REST was clearly a bottleneck. After knowing that REST is clearly a bottleneck, we again profiled in the next iteration. And there, after looking, we used JStack here. We collected thousands of samples using JStack and looked at what is the most common stack everywhere on all the threads. And we realized that this is the stack which was the most common, that we had a debug logging turned on, right? So every request which comes, we were doing debug logging in a file, and that was our bottleneck. So we identify a setting to disable, to turn it off, to make it warning level, not even info. After that, we could see that the performance of the REST and RPC was very close. And we could even saturate the SSD performance, the local SSD performance, with 160K requests per second. So after that, we asked our customer to try the same settings that we had done, and they were able to get around 5.5x more. And this was nearly 15x gain from the point where we started. And the customer now today is very happy. They are using HDInsight service in their production, and they are able to meet their throughput goals with enough margin to scale further. So here is the snapshot of all the, I will not go into details here, just listing all the tools which have helped us on the way. Just compares, like on Windows, what are your options, and on Linux, what are your options for different categories. So basically one question everybody will get, like if you use cloud storage, people think that, oh, it could be high latency. right, compared to local SSDs. So how do we overcome, do we have any options in HBase to overcome such a high latency? So I would just highlight a bunch of features which are there in HBase, which are very helpful, and they have provenly helped us in our HBase as a service infrastructure. So those two main features are multi-wall and bucket caching. So multi-wall minimizes the impact of write latency, where you can do writes in the parallel. So we could get the same performance with less number of region nodes, with less number of worker nodes. And bucket caching, it has provenly, since the VMs on Azure have local SSDs, if we turn on the bucket caching, that give nearly 20 to 30x performance gains to customers. All right, so.
Thank you very much.
Thank you.